Hi, this is Jeff from the Ozark Mountains. That's in Missouri, in USA. Today, we're going to talk about Commodore 64 power supplies. Well, specifically about some oddball Commodore 64 power supplies that I've collected over the years. Now, about 3 or 4 years ago, my very first video on YouTube was about Commodore 64 power supplies, and I've been wanting to go over these oddballs that I didn't cover ever since then. Well, let's jump right in and have a look. This video is brought to you by PCBWay. It's easy to jump on their website and get your quick quote for your next circuit board. They also offer CNC services, 3D printing, enclosure making, everything you need for a complete product. They also do surface mount and through-hole assembly, stencils, and a range of other products and services. If you need advanced circuit boards like flex boards, microwave boards, that type of thing, they got you covered there too. Also check out the PCBWay 4th PCB Design Contest. See the link in the description for more details and enter your own PCB design. First, let's review the original Commodore 64 power supplies. Here we have the first power supply for the C64. This one is repairable, it is not potted in epoxy, and it just takes 4 screws to open the case. It's the part number 902503-02. All the components in this power supply, the transformer, the regulator, the heatsink, they're all properly sized. If you can find one of these, it's a good one to have because you can rebuild it and it'll work fine for years to come. Now here is the infamous black brick of death. These were not reliable power supplies even back in the day. Every part inside this power supply is undersized. The transformer, the heatsink, and the regulator. It was not very well made. They are filled with epoxy, so they are not repairable. However, that epoxy is a better thermal conductor than air, so it does a good job of transferring the heat to the outside of the case. I would not recommend that you use these with your Commodore 64. And then we have the white brick, which externally looks the same aside from the plastic color, but inside it is built much better. The transformer is the proper size, the heatsink is larger, and it has a beefier 5-volt regulator. It's still epoxy filled, so you can't fix it. So I would still recommend that you do not use this one today. I did do a component level teardown on these two. The link is in the description down below. This is the Phoenix CPS-10 power supply. This was an aftermarket power supply that was available back in the day for the Commodore 64, and it is a really good unit. This does not use a 7805. It has a different type of voltage regulator chip, which uses a large current pass transistor, so it is much beefier. If you can find one of these, they are a really good unit. They're easy to open up, and you can check everything, and it'll work for years to come. Okay, on to our 3 oddball power supplies. The first up is this Suncom. This is also an aftermarket power supply that was available back in the day. This is the model number PS100. It is a 1.7 amp 5-volt output, which makes it more similar to the white brick. This is a sealed unit. It's not repairable, but I don't know if it is potted in epoxy inside, and I don't want to take this unit apart to find out. We will test this a little later and see how it works. The next up is this Microline power supply, which is another aftermarket unit from back in the day. This one is rated 1.8 amps at 5-volt DC and 1 amp at 9-volt AC. I think that 1.8 amps is rather optimistic. One thing that caught my attention right away is it says, under full load conditions, case temperature may exceed 60 degrees centigrade. Yeah, that is really hot, and that is a big red flag that this might not be a very good power supply. Now this one we can't take apart, so we'll test it and pop it apart later to see how it's made and try to come to a determination whether it might be a good power supply to use or not. And for our third oddball, we have what looks like a normal European Wedge type Commodore 64 power supply. But if we flip it over, we see something kind of unusual. A 110 volt, 220 volt voltage selector switch. Well, that's kind of odd, isn't it? These power supplies were made by the German Commodore factory for use with systems that were sold on US military bases throughout Europe. We saw a 1571 that was made in a similar fashion recently, and I'll link to that video in the description down below. These are somewhat repairable in that the transformer is potted, but the voltage regulator board is not, so you can get in and do some repairs and keep these going for years into the future. Here is our test setup. On the oscilloscope, the yellow trace is measuring the 5 volts, the blue trace is measuring the 9 volts AC. We've got my cheesy little dummy load here. I've got my multimeter where I am going to check the resistance of the output and input to the power supplies before applying power. And once we check that, then we'll go ahead and see what the waveforms look like on the oscilloscope. So first, let's try to make sure these power supplies are safe before we plug them in. We've got the Suncom on the bench now, and the first thing I want to do is test the resistance of the AC input. We're just measuring across the primary of the transformer here, so we'll have just, a few ohms, say maybe 10 or 20 or 30 or something along those lines. Now we're going to move on to checking the output side of the power supply. Now the 9 volt AC output is just the secondary of the transformer, so we're going to expect a lower ohm reading, say just a few ohms. And once I get the probes on the right spot, we see there's about 2 ohms, which is just fine. Now we'll measure the 5 volt DC output. The exact resistance is going to depend on the exact regulator they used, and it's not super important. We just want to make sure that it's not shorted out. And after fiddling to get the probes just in the right spot for way too long, we can see we have around 100 ohms, which is fine. So we know it's reasonably safe to go ahead and plug this power supply in. So we have our Suncom powered up here, and we can see we've got a good AC waveform. And if we look, it's measuring about 30 volts, but that is the peak-to-peak voltage. That's not the RMS voltage that we would normally be measuring, so we'll take a look at that later. If we look at the yellow trace, we see we have a nice steady 5 volts, which is great, but this is without any load. Let's go ahead and switch in a 1 amp load on that 5 volt output and see what that looks like. Yep, that still looks great. Very little voltage drop. Let's go ahead and kick it together. And, oh yeah, that's good too. So it looks like this is doing a good job outputting the 5 volts. And one interesting thing is notice how when we kicked in that full load, we see a little distortion in the AC sine wave. There's nothing wrong with that. It's just kind of interesting. Here I'm measuring that AC output, which we saw as about 30 volts peak to peak on the oscilloscope. When we're measuring with a meter, a true RMS meter, we notice that it shows about 10.21 volts. So that just illustrates the difference between a peak-to-peak measurement with AC and the actual RMS value that we're more familiar with. Next up here, we have this little Microline power supply. And I remembered I had this set of wires made up just for testing these sorts of plugs. And I have the orange and yellow on AC and red and black on DC. I set my meter to ohm scale. So all we're interested in here is that we have something that's reasonable. Yeah, about an ohm on AC. That's fine. And we should have 100-ish ohms. About 2K. Okay, we can live with that. Okay. So now I'll slip that back to DC just in case we need it. We'll plug this guy in. So with our Microline power supply plugged in, we can see we've got a nice 9 volt AC signal, but we have butt kiss on the 5 volt line. And I'm wiggling the cables and all sorts of that kind of stuff here, and it's not making any difference. So this thing might not actually work. We'll have to take a look at it. Oh, but wait a second here. The load is still on, and if I kick the load off, the 5 volts comes back up partially, although it's acting like it's loaded down, or there's a big voltage drop due to some high resistance in the cable or the connection or something. So maybe there is a problem in the power supply, but maybe it's just a loose connection. So we'll have to take it apart and have a gander. The one nice thing about this power supply is it's easy to take apart. There's just one Phillips screw on each side, and then we can pop the cover off. And inside we can see that the circuit board is soldered directly to the transformer. We've got a couple fuses, a big smoothing cap, and there are actually two voltage regulators which are just kind of pushed up against the metal case. That's kind of an odd way to do it. Well, if we rotate it around to the back, we can see where the thermal paste has pushed through the holes. And oh, look at that. A bug fell out. Huh, maybe there was a bug with this thing. With the unit plugged back in now, we'll go ahead and make a 5-volt measurement right at the circuit board, being careful to stay away from the high voltage terminals. And yeah, we've actually got 5.22 volts here, so maybe we have a connection problem, a broken cable, or something like that. I did load test the power supply, and I had 5 volts at the circuit board and at the dummy load, but I lost some of that footage. The only thing I can guess is that from unplugging and plugging in the DIN connector to the dummy load a few more times, that it might have cleaned off some oxidation on that connector, and that was the problem after all. At any rate, now it seems to work. This is the transformer out of one of the white brick power supplies, which was much bigger than the one that was in the black brick. This transformer is actually properly sized. You can measure the dimensions of the transformer and weigh it, and that will give you a very good idea of how much wattage it can handle. Compared to the transformer in this Microline, it is much larger. The difference is that between the black brick and the white brick. So yeah, I'm saying that this transformer in this Microline power supply is undersized. So I wouldn't recommend using it. Now we'll move on to our Wedge power supply, and we'll ohm out the AC input, and we have about 17 ohms, which is fine. When setting up to ohm out the AC and DC outputs of the power supply, I noticed that the DC output pins are in a slightly different position, so I'm not sure if this is going to work with my load tester or not. We'll have to see how that goes. On the AC output side, we have less than an ohm, but that's fine. It's not a direct short. It just depends on the transformer winding. Then we'll move over to check the DC output, and we have about 250 ohms, which is fine. Now we're connected to the dummy load and plugged in, and we've got a good 9-volt AC output, but we have nothing on the 5 volts, and that is most likely because of our pinout difference on the connector. The bottom 2 pins are the 5-volt DC output. On the other power supplies I've tested, the pin that's up a little higher is on the other side of the lowermost pin. So we're going to check the documentation to see what's up with this. I found the documentation that I printed out when I did my very first video on YouTube about the power supply connector, and I've made some notations on here about the views of the connector and things, which is always very important when you're looking at connector pinouts. So if you're drawing one, include that. We can see here that either pin 4 or pin 5 can be used for the 5-volt output, so I'll have to modify my little dummy load here to accommodate that. What I did was run a second wire from terminal 4 up to this little 5-volt bus that goes to the common of the 2 switches. Now get everything hooked back up, and we'll fire it up and see if we have 5 volts out now. We have everything connected back up now. We've got a good 9-volt AC, and we've got good 5-volt DC. So we'll go ahead and click on half of the load. There we go. Oh, that looks good. Let's click on the other half of the load. Ah, all right, our voltage didn't drop that much. So this old Wedge power supply is actually working really nicely. That's excellent. What do you say we take a peek inside of this power supply and see what makes it different from the normal European Wedge type power supply? These types of cases are glued together, ultrasonically welded. And if you're lucky, what you can do is take a screwdriver about this size and a rag, and you want to start kind of where the cords come out. That's usually the weakest spot. Or you just putting the rag on there so we don't ding the plastic. And I've started on this area already, and I've got it kind of separated to about there. Yeah, there we are. We're up to that connection now. So what I'm trying to do there is just hold the part of the case that's already separated apart. Okay. There we go. Okay. These two pieces are separate, which is good. That'll make it a lot simpler. Okay. I'm going to try. There we go. Now we got that loose. Oh, okay. We got some post on here. These two came out of the epoxy. These two did not. What do we have inside? So if we take a look at this thing, we can see we've got our voltage selector switch here. And really it's kind of bodged in there. Got the blue wire from the AC cord, comes in, goes to the voltage selector, it goes down to the transformer. It's got other wires just kind of soldered to the switch, and our switch was just glued here. So I wonder, on the regular European Wedge power supplies, is this angled plastic in there? I'm guessing maybe originally it was designed to push against the epoxy brick to keep that, if it came loose, from flopping around in there. So let me know, if you would, in the comment section down below. So they probably used a different transformer to have the windings to give them the voltage selection, bodged in the switch. And the voltage regulator board is the same, from what I can tell. We've got the AC rectified here. There's some diodes on the underside here. We've got wires right here coming up from the transformer. It's rectified. There's a filter capacitor underneath here. And these three terminals are actually the voltage regulator, which you can just see there buried in the plastic. It's attached to a large aluminum heat sink, so it's got a proper sized heat sink. And let's see if we can pry that open there. There we go. So yeah, we've got our 4 diodes in there, the smoothing cap, smaller smoothing cap, and a bleed resistor. So you can see how the board starts getting a little dark by the rectifier diodes. I'll be careful not to bend that too much. I'll break the regulator. So you can repair these. You can desolder the regulator here, replace the capacitor and the diodes, and maybe space the diodes off the board a little bit to keep them from heating up the board so much. And if you were careful, you could chip the regulator off of that board. I think Frank IZ8 DWF may have come up with a switching regulator board to replace this. I guess the thing is, if you're trying to chip the original regulator out of there, you'd have to go down far enough to get to the screw, which I'm assuming is in there, and you might have problems getting that out. It is at least somewhat more repairable than the North American black and white bricks, which have everything epoxied in there. So I'm not sure. Maybe I'll go ahead and clean this thing up and see about redoing the circuit board here. It'll be kind of a novel power supply. Well, I hope you've enjoyed the look at these oddball Commodore 64 power supplies. I think probably the most unusual is this 110, 220 volt European wedge type power supply. Imagine there weren't too many of those made, whereas the other aftermarket supplies were probably quite a few of those were sold, given how often the brick power supplies for the C64s failed. So what's my take on these three unusual power supplies? Well, I'm not too thrilled with the Microline power supply. The transformer was undersized. The way the voltage regulators were just kind of stuck on the metal case wasn't too good. Them saying the case might get up to 60C, no. It's an interesting collector's item, but I wouldn't use it. I'm not sure how the Suncom is made inside. I don't want to take that one apart to find out because it's working now. And then again, that's just a collector's item for me. Of course, the original black and white bricks that we had here in North America, don't use those. They're not reliable anymore. They weren't even that reliable back in the day. That CPS 10 power supply that I showed at the beginning there, that is a good vintage aftermarket supply. If you can get a hold of one of those work really well. These unusual 110, 220 volt European style wedge power supplies, if you can get one of these, you can rebuild this enough that it'll be good for many years to come. Be a nice, safe, well-working power supply. As far as a new power supply, I really like the one that Kevin Autumn makes. I've used one of those before. It's a nice small unit. It's very well made. I think he mainly sells those through Facebook. So if you find one of the Commodore 64 groups on Facebook, you'll probably find him there and contact him if you want one of those. I highly recommend them. I'd like to take a moment to say thanks to everyone who helps support the Hey Bert channel through Patreon and other means. It is greatly appreciated. If you have any questions or comments, well, leave them in that comment section down there below. I would love to hear from you. Well, until next time, bye.